Hi, you guys have been learning for the last little bit about rigid transformations, reflections and rotations and translations and all those rigid transformations. And we're going to just take that a little step further today, kind of review it a little bit, and we're going to learn a new vocabulary word. So we've got this shape, and I'm going to actually copy it so that we can remember what it looked like in the beginning. Okay, so we're going to play with this shape, but we're going to know that it looked like that in the beginning. So let's go over here. So if I move it down like this, it's a translation, right? So I just translated this shape. My vector looks something about like this, right-ish. We're pretty close there. So let's look at these. Let's look at these after this rigid transformation has taken place. What about this angle? Is this angle still the same as this angle? It is. When we have two angles that are the same, we don't say that they're equal. We don't say that they're equal because this is geometry, and equal is usually used for numbers. We say that they are congruent. I'm going to write this here in a text box. Congruent. Make it a little bit big. Make it a little bit big there, okay? They are congruent. And the symbol for congruence, I'm going to go ahead and draw it with my pen here, is a squiggly line and then an equals underneath, okay? That means that they are geometrically equal. Those two angles are the same. What about these two angles? They are also congruent because we had a rigid transformation, and a rigid transformation is going to preserve angles, right? These two angles, I'm going to do 3 now because they're a different angle, still congruent. What about side lengths? Did the side lengths change? Did the side lengths change at all? Did this length change? Let's say this was 6 centimeters. Well, guess what? These are going to be congruent, so this is also going to be 6 centimeters. Now, what if I rotate it? Now, I'm going to erase my translation vector because it's going to get in the way. What if I rotate this guy? What's going to happen there? Let's grab this and let's grab this and let's rotate it. Boom, we just rotated it 90 degrees. Are all those things still congruent? Is this angle still congruent to this angle? You betcha. Is this angle still congruent to this angle? You betcha. This angle still congruent to this angle? It totally is. Why? Because rotation is a rigid transformation, and rigid transformations preserve angle lengths that are still congruent. What if, let's go really crazy, we've translated, we've rotated, now let's reflect it. Boom, we reflected that guy. Everything looks all backwards, right? My words are backwards, but are the angles congruent? Boom, boom. Are they still the same angle? Yes. Are they still congruent? Yes. What about this angle and this angle? Still congruent? Yes. What about this side? It's backwards, but is it still 6 centimeters? It's still 6 centimeters. So they're still congruent, okay? So congruent means they're geometrically equal. Same thing as being equal, it's just in geometry instead of in algebra or arithmetic, okay? So what does that mean for us today? So let's look at these two. So I'm going to look at this, and I can see that this one's backwards, and it's been rotated, and it's been reflected. So congruent means they are the same. Here's another word. Congruence. A congruence is something that preserves, that makes it so that it's still congruent. But we did 3 congruences on these little guys to make it move over here. What did we do? We did a transformation. We did a rotation, and we did a reflection, right? So if I was looking at this and I was going to say, tell me the sequence of congruences that you would take to get from this guy to this guy. We're going to call this guy, we'll call him Amazon. And And we'll call this one, because it's not the same thing, we'll call it, it's been through a series of rigid transformation. I'm going to call it Amazon Prime. Okay. So what did we do to get from here to here? Well, we first did a transformation, then we rotated it, and then we reflected it. And that's what you would tell me. So let's go over to the assignment. Let's check this out. This is your assignment. So you're going to say, describe the sequence of basic rigid motions so that S1 is congruent. So we got the squiggly sign that means congruent to S2. So I've got S1 here. There's S1 and there's S2. You're going to describe to me the sequence of basic rigid motions, the congruences that take us from S1 to S2. Well, clearly I'm going to have to translate, right? Maybe I'm going to have to, they're flip-flop from each other, so I'm going to have to reflect, and I'm probably going to have to rotate. You describe how you would get S1 onto S2. Is there a right answer? No. Is there a wrong answer? Yes. But there's going to be more than one way to do this, right? I want you to think through it. This is a really valuable skill to be able to think through, okay, what am I going to have to do to get from here to here, and kind of that project planning. So let's going to be, now we're going to do it. We're going to perform the sequence of a translation followed by a rotation. So we're going to translate this guy, and you guys are going to be able to do this on the Kami app, so you could move it up and do your best to move it. And then we're going to rotate it. And then you're going to answer the question, is X, Y, Z going to be congruent to X prime, Y prime, Z prime? Are they going to be congruent or not? You can tell me that. And then we've got two right angles with lengths shown below. Is there one basic rigid motion that maps one to the other? So here's the question. So can you do this in one motion? I don't know. I actually do know, but I'm not going to tell you. But can you do it in one motion? And then we've got the same two right angles. If you can't do it in one motion, can you do it in two or three? And how would you do that, right? Tell me how you would do it. And then we've got these two rays. Tell me how you're going to map OA onto OA prime, and then tell me how you're going to map OA prime back to OA. And it's going to be a little bit different, right? One of them you might rotate first and translate, and then the other one. But this is kind of a review from the last unit, heading into this next unit. But we want to just really focus on the congruent, and rigid transformations preserve congruence, right? It's still going to be congruent after the rigid transformation. It doesn't matter what you start with. We can start with this arrow right there. We can, let me undo that. We can, let me select this. We can rotate it. We can reflect it. We can translate it, and it's still going to be congruent. We can put this all over the place, and it's still going to be congruent. Anytime you do a rigid transformation, it's going to be congruent afterwards. All right, I will check in with you and see if you guys need any help.